What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So, guys, one thing I should mention to you, right, is that if you do happen to hear the sound of water in the background, well, that is because it is raining pretty heavy on this side of the world. So, that's the first thing I wanted to mention. Also, you're going to notice and find out now, guys, that from this video onwards, this is a new tutorial series, right? I told you guys in the community section of YouTube that I've planned a NumPy and a Scipy tutorial. Okay, so we are working with these packages in Python. So the next few videos or so, will be about that topic, NumPy and Scipy. So NumPy, Scipy. Okay, guys. So since this is the first video, I'll just kind of, give you some insight into what this is, what NumPy is, what Scipy is, why we use it, in what programming language we can use it, and so on. So let's talk about this, guys. So one more thing that I should mention to you guys, I'm sure you'll agree with me, right? That I mean, people often, I don't know, have the misconception that the technology field does not involve or comprise theory, right? And well, coming from the technology background, as you know, if you are studying or so on, or if you are just technologically inclined, you will realize, right, that in reality, in today's world, whether you're studying a computer science degree or a software engineering degree or any qualification that's a part of the technology stack, right? The discipline of technology, you'll agree with me when I say that theory is really hardcore, right? There's a lot of theory. So I just wanted to, let you guys know it at an early stage, right? At the moment, the channel has about, I think, 105 subscribers or so, or 106. So I will definitely keep this goal in mind, right? When we reach 1,000, 2,000 subscribers and so on, I would like to make a video, a single individual video that highlights the goal of Machine Mentor Shivek, right? Our channel. As part of this video, I'm just letting you know, to those of you who are watching this channel, right? My goal for this channel, for Machine Mentor Shivek, is to post all the work that I'm studying and currently studying in my degree on the channel. And that's not all. My goal is to post tutorials on literally any and every piece of technology, whether it's a programming language, a new concept, a new piece of technology, right? My goal is to post tutorials on the channel, okay, to help you guys, to motivate you guys, and so on, right? And I should mention as well that my goal is to make the theoretical part of information technology less intimidating to my fellow colleagues. That's my goal. That's one of the major goals, okay? Because the theory portion of technology really catches everyone off guard, honestly speaking, from what I've noticed as well, from what I've witnessed, okay? The theoretical aspects, I would say school kind of um, offloads it onto us in, I would say, an improper way. It's not entirely structured, and I think that's what makes it intimidating. Well, my goal is to have videos that really are just casual, in which we just talk, I talk, you listen, and we can have a discussion in the comment section as well. Okay, that's the goal. So I have a lot of tutorials and stuff planned that I want to post on the channel, but all of that will be done as time moves on, right? For now, we are dealing with NumPy, SciPy. I have intentions to post about natural language processing, artificial intelligence. Really, guys, because what fascinates me the most is everything that revolves around the concept or topic of intelligent behavior in machines. Okay, intelligent behavior in machines deals with all of our AI stacks, or our AI sub disciplines, you know, it's interesting stuff. So now that that's out of the way, I think we are ready to dive into the first lesson, or first, yeah, you can call it whatever you want, tutorial, exercise, or lesson, or lecture of our NumPy and SciPy tutorial. So this tutorial or this video won't be anything, you know, hardcore. I'll just sort of get you up to speed with what exactly these words are, NumPy and SciPy, and you know, we'll take it from there. Okay, guys, so let's begin. Now, the important thing is you listen, okay? Listening is very, very important. So let's begin. So guys, NumPy and SciPy, right? So if you have experience or you've heard of NumPy and SciPy, that's good, right? That means you just have, you know, I would say, you have exposure, to what this is and what how they are used and so on. But if you don't have to stress about that, guys, because I am here to explain to you from the basics. Okay, so let's talk. And also, if you guys have any questions or anything, you just leave it in the comment section and I'll be glad to respond if I can be of assistance. So guys, NumPy and SciPy. Okay, you see, NumPy and SciPy are referred to as packages, okay, dependencies. And the programming language that we are looking at these packages is called Python. Okay, so to give you a bit of insight into Python, NumPy, and SciPy, basically, Python is the world's most popular programming language. Okay, at the time of recording, which is basically the 11th or the 22nd of November 2022, Python is the world's most popular programming language. And now, you see, Python has been developed or was developed by Guido van Rossum. Okay, my apologies if I got the name incorrect. So that's another interesting fact. Python is the world's most popular programming language and it was developed by Guido van Rossum. Now, Python has pros, Python has cons, okay? But to be honest with you, from my perspective, Python has mostly pros, advantages, okay? Because if you are considering things like portability, flexibility, the syntax of the programming language, the style of the software, the style of the language or syntax structures itself, okay? The extendability, the versatility, you know, these are all just adjectives. We are just describing the programming language. All in all, Python is an all-rounder. That is why it's referred to as a general purpose programming language. Now, you see, what kind of sets Python apart as well from our other languages such as, you know, C++, Java, and so on. Python uses and relies heavily on indentation. Okay, indentation is what gives our code structures, I would say it gives it meaning. Okay, because Python relies on indentation. Indentation is basically spaces. You can use the space bar or press the tab button, and that's what Python's compiler and interpreter rely on to actually, you know, begin executing. Indentation helps Python understand where does one block of code start and where does one block of code end. Okay, so that's that. Now, as a result of this, Python is very easy to understand. Okay, if you're a beginner and you're watching this tutorial, trust me, Python is a simple language. You just have to take time to read and understand the concepts. Okay, with the stuff that I have about Python on the channel so far, those tutorials, honestly, those tutorials are more than sufficient to get you up to speed to an intermediate to advanced level of programming in Python. Okay, so guys, you see, Python is often compared to faster languages in inverted commas. Well, the truth is Python is slower than our languages such as C, C++, you know, Java, Fortran, and so on. Now, the reason is because Python is an interpreted language, whereas C++ and so on, the ones that I mentioned, they are known as compiled language. Now you may ask, what is this? What is this? Doesn't make sense. What do you mean by interpreted and what do you mean by compiled? Well, to summarize it and put it simple for you guys, you know that, for example, I'll take C++, right? A C++ program cannot be directly executed. Okay? We've first got to compile it, which basically means like you've got to like compress it. You've got to run through the entire code and you sort of create something and you take the thing that's created and you run that thing. That's what compile means, okay? Because if you've coded in those programs before, you'd realize that when you first compile the program, it gives you a file that's unique to that language, okay? And you run that file at the end of the thing, at the end of the day, and that's what compile means. Whereas interpreted is like Python, okay? We can run the script directly. We don't need to compile. Compilation occurs during runtime, not before. They are not two individual processes, okay, logically speaking. So I hope that makes sense, guys. Now, that's fine, that's good. So, coming back to our little discussion, right? We said Python is not as fast as a Java or C sharp or whatever. Now, that's a fact, but that does not bring Python's popularity down. Reason being, it all stems back to this concept of dependencies. Dependencies is like support. Okay, it's support for a programming language, and Python has over 200,000 libraries, packages, or dependencies. Call it what you want to call it, right? As long as you understand. Python has over 200,000 dependencies or libraries to offer support to the developers. And you get specialized packages like JSON, Ceton or Cython, whatever you want to call it. And I'll just write that down, right, in case you guys don't know how to spell that. Okay, JSON, Ceton, and so on, that actually enable us to integrate. We can mesh or merge two programming languages together using these specialized dependencies or packages. And as you can tell, can you imagine having the ability to merge C or C++ code with Python? Okay, that gives us a huge speed advantage. Okay, but if a question is ever asked, if JSON, for example, is JSON faster than Java? The answer is no. Okay, is Ceton faster than C? The answer is no. Those programming languages will always be faster, okay, than the merged version of it with Python. So that's interesting to know. So I hope you guys are finding this interesting so far. At the moment, we are on 13 minutes into the video, but we'll keep going for a few more minutes. So guys, let's talk a bit now about, you know, uh, the concept of maths, numbers, computations, processing, etc. Right? That's all around us, especially in the field and in the world of technology. Processing and numbers and numerics are all around us. Okay, whether you're coding in any programming language, whether you're working with machine learning, any of the disciplines. Okay, now my point is, because of the fact that we are dealing with numbers, okay, and because of the fact that Python is not limited to only the technology field. Python has its own dealings in, the physics field, the chemistry field, the geography, and so on. Now, because of this, we needed a way to actually be able to process numbers very, very fast. And this is where Scipy and NumPy make their entrance. Okay, Scipy and NumPy are actually referred to as the powerhouses of scientific computing in Python. Okay, you'll often hear whether you come across books, articles, or any informative, pieces of information, you'll often hear them like mention or refer to the packages as with regards to what they call scientific and numeric computing. Okay, once they talk about scientific computing or numeric computing in Python, you can be sure, you can be very positive that they are talking about NumPy package and Scipy package. Okay, so all in all, these packages make it very easy for us to process numbers. Okay, that's the main aim of Scipy and NumPy. So you may ask yourself, right, why, like you may ask, I just told you that Python has like over 200,000 packages. Okay, and you may ask now, out of those 200,000 packages, why do we have to use NumPy and SciPy? Okay, you're telling me out of those 200,000, there's not, more or other packages that can do better than NumPy and SciPy? Well, that's something I will not be able to answer entirely, guys. But what I can tell you is that NumPy and SciPy to date are the most powerful and most popular packages that are used in Python for numeric and scientific computing, or just in general for dealing with numbers and arrays. Okay, now this leads me to talk about my next point. This tutorial, guys, assumes that you are familiar with the concept of, arrays or lists in Python. I will not be talking about the basic features of Python. I will be demonstrating to you the features and methods and functions that are available to us from NumPy and SciPy. So first we will tackle NumPy, okay? Now, I'd like to mention to you, right? You know, basic operations, when we talk about, as I said, when we talk about scientific computing, or numeric computing, you may ask, what does this involve? When you say scientific and numeric computing, what are we talking about? Okay, so the answer to that question is that we are actually talking about arrays, matrices, integration. We are talking about equations. We are talking about statistics. Okay, much more. Literally, guys, any numeric computation can be achieved and done with NumPy. NumPy provides a wide variety of processing and logical transformations that we can apply to numbers. Okay, so NumPy and SciPy are very powerful packages. Okay, now Python does not have built in built in built into Python, it does not have like these default functionalities that we can use to process, an array of millions of records. There's nothing of that sort that exists. It's just the base level array that we work with and we have access to. NumPy takes this base level array and it basically levels it up, giving us what we call a multi-dimensional array. Okay, you'll often hear them refer to NumPy array as ND array. So I'll zoom in here. Okay, that's good. I just zoomed in a bit. Okay, guys, so let's go over that again. So this video at the moment is 19 minutes long. So that's just to make you aware. Now, guys, let's talk a bit about NumPy and SciPy. Okay, we are talking now about the actual packages. Okay, so a few of the terminologies that you will hear me speak about, you don't have to stress about them for now, right? As with any book that you read, they mention topics and concepts to you in the start and they gradually build up on that as they go further into the book. It's the same concept we are using, okay, for the videos. I will mention one or two concepts now and again. You may wonder what they are, but sooner or later you will be working hands on with these concepts. Okay, so let's talk about NumPy. Now, guys, NumPy specializes in numerical processing, right? And it does this by using multi-dimensional arrays, as I have it here for us. It's called ND arrays. That's when we know we are referring to multi-dimensional array. And the thing about a multi-dimensional array is that the array itself contains elements. Yes, we know that. But the multi-dimensional array or ND array actually allows for element by element operations to be performed. Okay? It's a procedure or a process that affects each element individually. That's the key thing to take away about ND arrays. Okay? Now, you'll also hear them refer to a process known as broadcasting. Okay? Now, that is the process that actually allows for elements to be processed element by element individually. Okay, so I hope this is making sense. I hope you are finding this interesting. Okay, now, you know, arrays really, it all stems down to maths. Okay, plus, minus, divide, add, subtract, whatever you want to call it. The thing is, the point of having NumPy as well, another important point, is that by having NumPy and access to what they call an ND array, we have the ability to perform linear algebra and mathematics without modifying, without changing the NumPy array before. Okay, what this means is that during a specific instance, we can dynamically change the contents of that array using element to element access, which is basically broadcasting. That's the process of affecting each element individually. It's known as broadcasting. So, really, this is just me explaining the logic behind what you will see in Python. So, you need to understand logic before you actually view the code. Now, I should mention to you as well, right, that in some programming languages, right, I don't have an example here as I've never really faced a situation or I can't recall, but in some programming languages, right, if you want to have an array with a few elements that are not in it, you'll have to create a new array, okay, that has or reflects the changes. But as I mentioned, with a NumPy ND array, we will have the ability to actually delete or add or insert or affect elements within the instance. Okay, we'll have the ability to filter with NumPy arrays. We'll have the ability to actually filter the elements. We'll do this by what's called applying a mask to the array. Okay, now let's talk a bit about Scipy. Now, Scipy is a library that's actually built on NumPy. When I say that, I mean that the backbone of Scipy is NumPy. Scipy is kind of like an elevated or leveled up package of NumPy. Okay, so that's important to know. Now, you'll find developers often saying that, SciPy takes scientific programming to a whole new level, right? But the question is how? Well, SciPy actually gives us access to much more advanced mathematical functions, okay, like integration, you know, equation solving techniques. We'll have access to special functions, optimizations, Fourier transforms, and more. Okay? Now, guys, I should mention to you, right? SciPy provides us with so many functions and features, as a developer, that really you guys will find that very, very interesting, right? The amount of features and functions that SciPy package has to offer is, I mean, some may find it overwhelming, but not if we break it down piece by piece. Okay, and we will have a look at all of the important functions and features that Scipy has to offer. NumPy specifically is one topic that I am eager to share with you guys. I found that really very exciting when I saw NumPy and worked with NumPy for the first time back in 2020. So that is interesting. Now, I should also mention to you, right, that this video at the moment is clocking, I would say, 26, 27 minutes. So I am happy that you guys, you know, understand what the plan is, what the procedure is for tutorials and the channel itself. So with this, we've covered a very, very good introduction into NumPy and SciPy packages. Basically, we spoke about all things that really matter when we are going to work with NumPy and SciPy. Going into the next video, we will deal with installation of the two packages. Installation is very simple. It's just two commands that you'll need to execute. So since we are in this video, if you are using Spider, utilize pip install NumPy, pip install SciPy. Okay, guys, doing those two commands in your IPython console, which is basically this portion of the screen here, right? Pip install NumPy. You do that, hit enter. Do the same for SciPy and hit enter, and you will have the packages installed for you. Don't stress though, because in the next video I will walk us through exactly how to install the package. Okay, so guys, with that, thank you so much for watching. Thanks for staying till the end of the video. I do hope you find this as interesting as I do. And with that, guys, good luck with your work, and I'll see you in the next YouTube video.